Hello everyone, welcome back to Exam Prep Tool. I hope you have been loving this series of important topics or concepts in machine learning, where firstly we talked about linear regression. Within that, we actually saw the variation as well: simple linear regression, multiple linear regression. Okay. Uh, then we talked about the KNN and K-means algorithm. One was supervised, one other was unsupervised. We talked about that. We solved some problem as well there. Then we talked about the naive-Bayes classifier. How does it work? And now this is the final topic concept within the series of important concepts where we will be talking about decision trees. So the way decision tree works is a little lengthier if you would like to just go touch the finish line. So with respect to touching finish line, what do I mean is actually saying that should one data point be classified as, let's suppose, one class or other class, that takes a little time. So that's why you'll rarely get a chance on that you are actually solving end-to-end problem on decision tree. It involves a lot of calculation as well. So it is going to be very rare that you will get such kind of a question. But what you might get is the important fundamental concepts with respect to the decision trees, which we will be talking about within this particular lecture. Okay. So what exactly is decision tree? How do we create decision tree? How does it help in like determining what should be the class of a particular test variable? We'll talk about all those test data point. Okay, we'll talk about all those things within this. So let's get started. So the topic is decision trees. Okay, decision tree. What exactly is this? Like it's again a kind of a, what should I say? Non-parametric supervised machine learning algorithm. Okay, non-parametric supervised machine learning algorithm. Machine supervised algorithm. Now, I don't know like whether you understand what is parametric or non-parametric. What do we mean by parametric or non-parametric is we do not really have any assumption with respect to the data. For an example, in linear regression, we assume it is linearly separable, or we will be able to fit a line over there. So the moment we have an assumption, we tend to have some like equation which should follow it. So we find parameters for those. If I assume that there is a distribution from which I'm getting this particular data, in that case, we need to determine the parameter of the distribution. But for algorithms, like if I talk about KNN, decision tree, we do not really have any assumption on the data. We just try to train, try to learn from the data without having any assumption about it. Hence, it's non-parametric. Supervised, like we'll be having some target variable. If it's classification, we need to say that, okay, what class it would be belonging to for a test point. And if it's a regression, then we need to determine what is going to be the value for this target variable. For an example, if I'm predicting what should be the demand, in that case, demand is a regressive target variable. What should be the prices of houses? Okay, something like this. What should be the salary of a person based on his skills and experience, and maybe the college. So all that stuff would be is generally part of regression. So decision tree can be used for both the things, regression as well as classification. But when we study, it's most of the time we study with respect to the classification, and we'll be talking about that thing only over here. Regression can be something which can be discussed in the paid course. You can definitely check out that. Okay, so let's just proceed with what exactly is the decision tree. So I'll give you just fundamental idea around what exactly it is and how do we actually create a decision tree. So you must have seen in your personal life as well that if you really want to decide what you'll be doing in 5 years from now, it depends upon a number of things. That okay, if you are able to crack a job in, let's suppose, Google, in that case, if it's yes, you would be having a different target. If it's not, in that case, you'll be having something different over here. Then you need to think about some more things. That okay, I would upgrade myself, maybe something like I would like to learn more about my fundamentals, do like that. Then I might try again for the Google, or might be that I would not be interested in Google, but would be in something like remote job, maybe, possibly. So we make decisions like this, yes no, based on kind of a thing for a situation, and then we come to a conclusion on the last a leaf of this kind of a tree structure. If you belong to the CS background, you know what is a tree. If not, so it's like forget about the data structure, tree data structure. Think about the parent hierarchy, our ancestral hierarchy. There is a parent, then we had, like their child, then their child, and something like this. And right now we are at the leaf node. If we become parents, we'll be having child. So that is something like this. So for a tree, the child, these are the child. Okay, for any parent, any node, these are going to be the child. For this one, these two are the child. For this one, these two are the child. But what are going to be the leaf nodes? Leaf nodes would be the ones at which our tree generally stops. So that means, for an example, right now we are the leaf node if we have not been married, or if we are not having any kind of children further. Okay, so that's like a leaf node in a tree. Other than leaf nodes, we always have internal nodes. Okay, and this is the branching we talk about. Okay, so this is the data structure we'll be using. And as I mentioned that, okay, if you are actually deciding for something, something like, okay, what would I like to gift myself at my 25th birthday, something like this, if you are planning. So what would you see in that case? That how much of money would I be able to make in that case? Okay, now depending on that, let's suppose you are actually thinking about going with your friends. So what I'm saying is, so you wanted to go on a trip on your birthday. Okay, now first of all, the first thing itself would be the budget. How much are you able to save, plus how much you'll be getting from, maybe like your parents might give, your grandparents might give, and some close relatives, they might give you some money on your birthday, something like, which generally happens in Indian families. So you have a budget formed. Now it can be a variation, like there can be variation for the budget. So for an example, you saved, or you could get only 5,000 total, or 10,000 total, maybe some rich people might get 20,000, or maybe much more than that. So depending upon the budget, then you'll be having something like this. If it's less than 10,000, you are going to decide something else. If it's more than 10,000, you're going to decide something else. So if it's like this, if it's less than 10,000, in that case, you'd like to go on a trip with your friends. You'd like to gift yourself something like this. If it's greater than 10,000, in that case, like you would be able to manage a lot of expense on your own. So you'd like to travel solo. Some people like solo, so it depends. Okay, so you'd like to go solo for a trip. Now with respect to the friends, how many friends are ready to go? So is it less than 3, more than 3, something like this? So you'll be having again something like this. Okay, and for the solo thing, you'll be then deciding what are the what should I say, hotspot right now, or what should be the ideal tourist places where I can visit. Within that also, you might have a criteria that whether you'd like to go for a like a hilly place, or a beach side, or a forest safari kind of a thing. You'll be deciding something like this. So we do take decisions something like this based on some of the condition. So the idea is, how you have been using decision trees in your life since like a long time, but you don't know about like how we actually use it in the business, or maybe in the industry. So this is exactly in a similar way we actually use the decision tree. Okay, now the idea again remains same. So if I have a data something like this, let me just begin with something like this. So right now, while just creating this particular video, so there is this Dhurandhar movie which had been released. Okay, so I would say that somebody would like this movie Dhurandhar or not, something like this. Okay, let's suppose I'm just creating an example for that. Okay, now the data set might contain something different, and this is a classification problem. So what I'll be having is just yes no. Do you will you like this Dhurandhar or not? So yes no, yes no, yes no, something like this would be there. Okay, Now and there is a data set which I'm actually like, which we can talk about. So over here, for an example, it can be something like, let's suppose, what is the age matters, what is the gender also matters. Okay, do they like spy movie? Like if they like spy movies, in that case they tend to like the Dhurandhar movie. The other thing can be, I can, yeah, like these three categories I can just talk about. Okay, so age, gender, and spy movie, like do they like or not? Now on the basis of that, I would like to decide whether someone, like let's suppose this is a guy, this is the first data point, who is having 23 of the age, male, and he likes generally the spy movies. So would he like Dhurandhar? So it's like most probably yes. If it's a male who is in, let's suppose, like 15 years of age, a male who doesn't really like the spy movies, there is less chance that that particular person would like Dhurandhar movies, because he's young also, so he doesn't know much about that. Okay, he would not be having that overall idea about how does these movie, like what do they try to show, or what is it exactly like to be in that kind of a world imagination. Because when you live it, then you enjoy such kind of movies better. Okay, and then there is a particular person, let's suppose female. Spy movies, I would say that they do not like spy movies, but sometimes there may be a scenario that somebody who doesn't like spy movies, they may like the just because of the action, or maybe I don't know, like the two countries, and the events which had been shown in that kind of a movie, like I hope you're aware. So somebody who might not have been into the spy movies, but something related to them, something maybe part of their life kind of had been shown in that life, in that film, in that case they would like them. So something like this. So I'm having such kind of a data, and then I just want to predict that whether somebody would like this movie or not. So what do we have to do first of all? So based on this data, first of all, I create my decision tree. Once I'm able to create my decision tree, now I'll bring in any test data point to say that. So for an example, you'll be telling me that, oh, this is a new person you're talking about, maybe age 35, a female, but that girl or lady like spy movies. So would she be interested in watching this movie or not? Okay, so based on this decision tree, we'll have the same thing, like whatever we'll be creating, that okay, what is the age, tell me, would it be going to left or right? We'll talk about that. Then in that case, whether that person likes spy movies or not, left or right, what is the age of that person, left or right? Then whatever would be the child node generally contains the information to predict whether a particular person would like this movie or not. Okay, and in a similar fashion, like if I want to say whether it's a cat or a dog, based on the properties or behavior, the attributes I'm having, I'll be able to say whether it's a cat or a dog, like I was talking about within k nearest neighbor kind of an example as well. Okay, so I hope this idea is clear, that how we will be creating it. Now there are two important questions which shall come to your mind. Important questions. This will determine how much of the understanding you get out of decision tree algorithm. Important questions you need to ask yourself. So the first question is going to be, what should be order of feature I shall consider to create branch at any node. To create branch at any node. See, I hope you know that at any point of time, I'll be having all the data points together. On the basis of that only, we are actually creating our decision tree. So we have all the data points at a node. Now, I would like to create the branch, like two side. of it. Now, what should be the feature I shall be using to split that? What should be the order? Shall I use, for an example, for our this movie thing? Shall I consider the age first? Shall I consider the gender first? Shall I consider the whether somebody likes spy movies or not? So, what shall I consider over here? This is the first question. Second, if it's what should I say? Uh, uh, if feature is continuous, how to decide split? See, right now over here you can see for gender, I know it would be either male which can go to the left or female which can go to right, or like vice versa as well. Females on the left, males on the right. And if it's spy movies, again, either somebody likes the spy movies on the left or do not like the spy movies on the right. Similarly, vice versa as well. We can go for the not liking spy movies on the left and liking spy movies on the right. So like we are clear with respect to this. But if I talk about the age, we have numbers over there. So in that case, I have to fix a threshold that if age is greater than 40, then left, otherwise right, or if age is less than 40, left, otherwise right, something like this. So how would I decide what should be that number 40 over here? Because we have a bunch of values present over here, 23, 15, 30 over here, or maybe something some more number of values are possible. So these are the two questions. If we have the answers to these, we will be able to create our decision tree. So we'll talk about each one of these one by one. So the idea is something like this. This will help you understand. So always idea of branching tells that I should get more clarity. Like I'm using the very naive language, very basic understanding to create it. Idea of branching tells that I should get more clarity on branching, whether somebody would like it or not. So for an example, you remember that we have actually picked up a particular feature, which is somebody likes a spy movie or somebody do not like spy movies. So I might say that if I bring that feature on the top, I know that people who actually like spy movies, there is the maximum percentage of the chances that they will like Dhurandhar. Okay. But for those who do not like spy movies, we might have some chances that we can turn. Basically, the chances are rare that they will like Dhurandhar, but there might be some scenarios based on the gender, based on the age, which can make them like Dhurandhar movie. So can you see, if it was yes to the spy movies, in that case, it's highly probable they will like it. So one part of the like classification is already sorted with the help of that. If I just use the whether they like spy movies or not. So I hope you can see that I'm able to create a branching in such a way that I'm getting a pure kind of a node on one side. Pure kind of a node means it will not be having any kind of mixed class. What do I mean by that? Let me just talk about this. So whenever we branch, we will again be getting some data points. For an example, let's suppose over here we had around 20 data points. Now, as I split it on the basis of whether somebody would like Dhurandhar or not, based on the idea of whether somebody likes spy movies or not. So let me just say with respect to the spy movies, I'm writing it. So if I'm doing it, let's suppose I get overall 13 data points over here and I get 7 data points over here, because 7 said we do not like spy movies in general. They're not saying that we do not like Dhurandhar right now, because we're training and we have the labels for them. So like we are getting 7 over here, which said we do not really like we do not like spy movies. There may be some cases who actually like Dhurandhar, but the number of data points I'm getting over here, 13, which said that we like spy movies, there is a like a high probability I might create a data in that way right now, just to help you understand that. Let's suppose all said they like Dhurandhar. Okay. So what I'm saying is, with respect to Dhurandhar liking, I'm saying 1 and 0. So all 13 are saying that we actually like it. And 0, like 0 means like who do not like Dhurandhar movie. There is this 0 count. None of those 13 said that we do not like. Okay. For this one, I might say that for Dhurandhar 1, that means somebody who's liking Dhurandhar movie, there might be this that I'm having around 2 people who said we like Dhurandhar movies out of the 7, and 5 said that we did not like. So I hope you can see over here, this is a pure kind of a node where all the data points I'm having belong to just one class. This is called pure node. And this is impure because I'm getting mixed class over here. Now, I hope you're getting the idea that we would like to get more and more clarity. So I'm getting some clarity over here. So that means, like, by intuition, if you can understand, the idea of branching should always be to reduce the impurity. Because right now, if I just talk about over here, what was the stats, overall stats over here? The overall stats said that, okay, 15 actually likes Dhurandhar, and 5 said we did not like Dhurandhar movie. Okay, so it was already an impure node. But if I use this spy movie based criteria, I am able to get a pure node over here where everyone is saying we liked. And over here, I'm getting some impurity, but it's still fine. We will be able to, decode it, how we can divide it further to get some purity if possible. But right now, with the help of this, I hope you're getting that the idea of branching is always to reduce the impurity. That means I should be able to get more pure and pure nodes. If not pure, it should be like near perfect. For an example, only 1 out of 18 or 2 out of 18 were saying that, okay, we did not like. So that proportion of, or the balance should be not maintained over there. It should be completely imbalanced. Then only it is actually going to towards purity. What do I mean by imbalance? If it is 50-50, in that case, we are not getting any clarity. Okay. But if somebody is saying that it's 90-10, in that case, with the help of 90, I'm already getting to the pure side of the node. 10 are the exceptions over here, but it's still fine. 90-10 is good. Okay, because I would say in that case that if I come to this particular nodes after traversing the tree, most of the people said that, okay, 90% of the people said that they generally like this movie. So whatever test point would come to that node, in that case, we will say that he will also like this movie. Okay, something like this. If this idea is clear, so that means what we actually talked about, we want to reduce impurity. And this gives us the answer. If it's a categorical feature, if we have categorical feature, if all are categorical features, we will calculate impurity because of each feature. Because of each feature at any level. At a level. The one giving least impurity, that particular feature is picked up. So I hope you're getting this idea that if I'm having all the categorical features, I would like to calculate the impurity for all of those. How do we calculate? We have a different way of calculating this kind of an impurity. Okay, so I'll just define some of the terminologies which are important over here. First is entropy, Gini impurity, information gain, okay. So what is entropy? I'll give you the formula for this first, and then we'll talk about this. Minus sigma pi log pi. We'll talk about this. Gini impurity and Gini index. So Gini index used to be something which I was not really aware of. I'll be very frank. But Gini impurity was I was aware of. I'll make it clear that what are these two things? How do they relate? They are nearly the same thing only. So Gini impurity, like the way we calculate the Gini impurity is like this. 1 minus sigma pi square. Okay. Information gain is nothing but it is written as entropy of the parent node minus entropy of on split. Okay. So I'm saying, okay, I'll talk about each one of these and then we'll understand how do they help in, what feature has to be selected. And then we'll go to the idea of what do we do with our continuous feature as well. Okay. So I hope you understand what is entropy. So if I just forget about summation P log P, just think about P log P. What does P log P tell? Just think about this. If P is do not consider the very extreme case, like considering P to be infinity. Sorry, not P. P is a probability. So P to be 1 or 0. These are the extreme values. If I consider P to be 0, we have a problem. Okay. Because of log, it might be giving you minus infinity, a problem there. But do not consider that, as in general we'll be getting close to the end, but we have a, what should I say, limit defined as well. So for probability 0 or 1, the entropy is going to be 0. Okay, so entropy actually talks about the randomness. Okay, uncertainty. What is the uncertainty I'm having? What is the randomness I'm having at any point of time? Okay, so for an example, if I talk about something like this, okay, you are tossing a coin. Okay, there are like what is the uncertainty related to this particular coin? If it's a fair coin, I know the probability is going to be to get head or tail. It's going to be 0.5. So 0.5 into log 0.5, you'll get some number. You'll be able to calculate. What do you get? Very easy. Just consider base of log to be 2 only. So if I just consider that, okay, let me just do that also for you to understand. So it would be 0.5 log 1 by 2. I'm writing it deliberately, or let me just write this one as well. 1 by 2 minus 1 by 2 log 1 by 2. This is when I'm talking about, this is for head, this is for tail. Okay, because the formula says minus sigma log p log p. Okay, so for each of the event possible, I'm just talking about what would be the overall uncertainty associated over here. So if you just look at this, what is it going to be? So you can just write it like this. Log of 2, you can write minus 1 over here, because these are to the same terms. So I can just write minus 1 minus log 2 inverse over here. Log 1 by 2, log 1 by 2, the coefficients were same. I added minus 1 would be the coefficient. Log half I wrote 2 to the power minus 1. I hope you know the formula. This power comes up over here. So it would be just log 2. And I said the base is also 2. So I'm getting this. So I'm getting highest uncertainty. Always remember, this is the value of with respect to the entropy. Maximum value which you can get, that is 1. So we know if the probability you always talk about is 50-50, I'm very much uncertain. This is the most random situation I am having. But if I consider something like, let's suppose an example of 70-30 or 80-20, and we'll use some calculator as well over here, need not worry. So if I talk about 70-30, 7 by 10 log 7 by 10, what is the value of that? Minus 3 by 10 log 3 by 10. If you just try calculating this, what you'll be getting is a value lesser than this. So you'll find that uncertainty is actually decreasing over here. Why is it so? Because when I'm saying that the probability of getting ahead is 7 by 10, that means 0.7. That means I am more sure of getting a head than tail. That itself is giving me an idea that uncertainty is reducing slightly, making room for my better prediction that it should be head next time. Okay, so if uncertainty randomness reduces, I'm more sure, and hence the idea over here, like why was I talking about? So idea is I would like to remove or lessen, reduce my uncertainty. I should be able to tell what should be like. I want to increase my predictability. How would I do that? I can decrease the uncertainty or increase the certainty. So with respect to this, if I just talk about what is log of 0.7, what is the value you are getting? It's minus 0.15. Okay, I'll multiply it by 0.7. 0.7. What did we get? Minus 1.08. So if I talk about what have we gotten? Minus 1.08 over here. Sorry, minus 0.108. My bad. I'll reduce this point. Point matters a lot. Minus 0.108. What about this one? What we will be getting? And yeah, this was minus 0.018 because log of 7 by 10 was minus of something. Now similarly, I'll just calculate for log of 3 as well. Log of 3.3. So that is minus 0.522, and I'll multiply it by 0.3 again, giving me overall minus 0.156. 0.156. So you can see over here what I'll be getting is 684.6 0.264. So you can see the entropy has dropped over here. Entropy was 1 over here, and entropy over here is 0.264. So this is telling me that if I'm having more clarity, if I'm getting an imbalanced idea, that means one is having higher chances than other. In that case, uncertainty is reducing or certainty is coming up into the picture. That means I'll be more sure about something happening, and that's what I want with respect to the decision tree also for splitting up the nodes. So Gini impurity would help us decide what is the impurity if I use this particular split. Entropy would also be helping me in a similar fashion. What would be the what would be the randomness if I use this split? And it should decrease, because if it decreases, that is something which I would like to use as the feature for split, because I would like to increase my certainty rather than the uncertainty. Okay. So I hope entropy idea is clear. So like how would I be using it in this context is something like this. So let's suppose after splitting, what I'm getting is, after splitting, I'll be getting something like this. So overall, I'm getting 10 data points over here. Overall, I'm getting, let's suppose 13 data points over here. And class 1 we are having is, let's suppose 8. Class 2 I'm having is, let's suppose 2. Class 1 I'm getting over here is, let's suppose something like 7. Class 2 I'm getting somewhere over here is 6. So the way we will be calculating entropy for this one and then for this one, let me just write that formula, because this would be something which will be happening in your numerical questions. As I said, they will never be asking you to create the entire decision tree. So if I say this is node A over here, this is node B over here, this was parent node over here, So what is the entropy determined by H of node A over here? So how you will be calculating minus what is the probability of getting first class. So 8 out of 2, like 8 out of 10, 8 plus 2, 10. So 8 by 10 log 8 by 10 minus what is the probability of getting another class, 2 by 10 log 2 by 10, and then you'll just get the answer over here. Okay, this will be giving you the entropy for this one, something over here. Similarly, you'll do the same stuff over here. What is the entropy of this one? You'll be getting something like minus 7 by 13 log 7 by 13 minus 6 by 13 log 6 by 13. You'll be getting something. Now the work is not done. Work is still not done. Why? Because right now I have gotten what is the entropy for this one, what is the entropy for this one. I need to calculate what is the overall entropy I'm getting. So I need to determine, because of this split, what is the overall entropy I'm getting. So to find out final entropy, we have to use the weighted average of HA and HB. Weighted average means it would not be a simple average HA plus HB by 2, because I had different number of data points over here, different over here. So we'll use that. So what would be the weight of this entropy? 10 out of 23 were there. So 10 in divided by 23 into what is the entropy of A plus 13 out of 23 into H of B. This is the entropy you'll get after splitting overall. Okay. And this would be called as the entropy because of this particular split, whatever you had. This way, you'll calculate entropy for each of the possible split. Now, you'll see where you are getting least entropy. Wherever you will be getting least entropy, that is giving you the idea that I'll be more certain for prediction if I use this particular split and would like to go with that. So we will be choose split which will have least entropy for split. Okay, I hope idea is clear. Okay, how do we use the entropy? If I talk about the Gini impurity, Gini index based idea, what do we do in that? So same idea, I'll just class one. Yeah, so we know the formula. So this was the parent. We had this A, B, 13 data points, 10 data points. Class 1 was, what was that? 8. Class 2 had around 2. Class 1 had 7. Class 2 had 6 data points. Okay, over here, 6. Now, how would I calculate the Gini impurity and Gini index? I'll bring in the idea for both. So the idea over here is Gini impurity for A. What is the formula? 1 minus summation of all the probability squares. So P1 square plus P2 square. So what is the probability of getting from class 1? So it is 8 by 10. 8 by 10 square minus other one is class 2. What is the probability of getting class 2? 2 by 10. So this will be giving me the overall Gini impurity. Similarly, I'll be talking about Gini impurity of the other child. What will be that? 1 minus 7 by 13 square minus 6 by 13 square. This would be giving me the impurity over here. Now, as I talked about, this is just half of the portion. I would like to know what is the impurity because of the overall split. Okay, so that means, and if I talk about Gini impurity, talks about impurity of a node, and Gini index is something which comes into the picture now. Gini index is nothing but kind of weighted average of Gini impurity only. So what I'll be doing over here, so 10 by 23 into Gini impurity of A plus 13 by 23 into Gini impurity of B. This gives us the Gini index. Okay. Now, whichever will be having least Gini index, that means ultimately giving me the least impurity, that is going to be the particular feature which I'll be using for the split. I hope you're getting this idea. Let me just repeat. It is similar to the entropy idea, but we are having different formula or terminologies, but the idea remains same. For entropy, we are decreasing the uncertainty and randomness. We want to be more sure, certain. So we want to reduce entropy there. In impurity, again, impurity actually, so you can just look at this formula also. What does this formula tells me? P1 square, P2 square, sorry, minus P2 square. Let's suppose I had pure class over here. So for one, P would be 1, for other, P would be 0. So what you'll be getting? 1 minus 0. I'll be getting impurity 0. So I hope you're getting what is happening over here. So if I'll be getting pure nodes, the impurity would be 0. If I'm having impure nodes, impurity would not be 0. It would be on the higher side. Okay. So I would like to use that particular feature for splitting, which will be giving me least Gini index. That means it will reduce the impurity most. Okay. So whichever split would be giving me the least Gini index, we would like to go by that. So these two are clear, I guess. Information gain is nothing but that also uses the idea of entropy only. So if I talk about information gain, that just this one, entropy of parent minus entropy of split. That's it. So I'm just writing it in my view over here. So entropy of parent, so like the way you calculate entropy of any node, you'd like to just calculate what is the entropy of parent. So you'll be able to calculate this minus, what is this? Because of the split, what is the overall entropy you're getting? And we just talked about, because of the split, the overall entropy would be the weighted average of these two. So we will place it over here. And then we would like to see what is the number. Now this difference actually gives us the information gain. And I want maximum information gain. And you can just relate these two. So we wanted to reduce the impurity. If this is coming as less as possible, this is constant, minus if this is decreasing, I'll be getting this maximum. So the idea remains same. I would like to decrease the entropy, giving me the maximum information gain. So if I'm using the information gain idea, whichever split would be giving me the maximum information gain, I would like to use that particular feature or that particular threshold for the what should I say, continuous variable. Forget about continuous variable right now. If I'm just going by the categorical variable, for an example, gender or whether somebody likes the spy movie or not, among these two, between these two, whichever will be giving me more information gain or least entropy or least Gini index, that would be chosen as the feature which I'll be using first, and then I'll be having a split. Then again, if I'm having pure nodes, good. If not, I would like to split that again. For the splitting, what would be the feature I'll be using? Again, we go back to the same idea. What shall be the feature I shall be taking? Whichever will be giving me the least impurity, least entropy, or highest information gain. And that way we keep on building our decision tree. So that is the overall idea. How do we create a decision tree? Okay. So I hope with respect to the categorical feature and how do we build decision tree, that particular idea is clear right now. Now, if I talk about the second question which we had in our mind, we'll answer that. And then lastly, we'll talk about like we will create a decision tree, and we'll also talk about some of the important things like with respect to like what should be the ideal scenario. Like there are some checkpoints or some important points which we need to consider in mind. So second question which we had in our mind, what was that? How to decide split for continuous variable. See, if it's categorical, it's easy. If there are multiple, more than 2 categories, if I can have more than 2 child, I can go by that. If not, I would like to go by somebody having this category, somebody not having this category. Something like this. If I'm having, let's suppose, a category where the values possible are high, medium, low, then in that case, and if I can have only 2 child, not more than 2 child, So I would like to go like this. If I'm creating a split, high and non-high, that means medium and low would be lying in one split. So I hope you're getting like what I'm saying. If there are multiple, like the category has more than two possible values, how do we do that? If we can have more than two child, then I would rather go by that. But that would be a problematic situation because a number of categorical variable might have multiple values. So that is not generally used. So we do this category, or apart from this, whatever are there, we just bring them all in one particular node. Something like this happens. So this is with respect to the categorical. Now, what with respect to what should I say? The continuous variable. So for categorical, it's clear. I'll be having a very clear split. But for continuous variable, where we had a value, for an example, a range, sorry, age, where age was 15, for someone 20, for someone 18, for someone 40, 35, 32, 31, 28, 29, 23. We have a number of values. What should be the value I should be deciding? So what do we do in that case? I'll just talk about that. I'll just remove this. So I'll give you the example. Let's suppose the age values we had. Age column was something like this: 22, 31, 18, 15, 35, 23, 40. Let's suppose we had only these values. Let's suppose we had only 7 data points for an example only. So what we will do is we would like to sort them up. Like this is not the general way. We would not really be actually sorting it up, but we actually create something over here. Let me tell you about this. So what are the values I'm getting? So it's 18. Sorry, there was 15 as well. 15, 18. Then we had 21 or 22. 22. Then we had 23. Then we had 31. Then we had 35. Then we had 40. So these are the 4 data points I'm having. Now, first of all, see, we were very much clear for categorical because we already had the split defined. Yes, no, male, female, something like this. For multiple categorical variable, again, we have to decide what should be that thing. So that also goes like this only. So now what we will be doing is we will find out the midpoint of each of these, what should I say, contiguous values or consecutive numbers. What is the average of 15 and 18? It's 33 I'm getting. So 16.5. What about 18 and 22? What I'll be getting? It's 20. For this one, it's going to be 45. So 22.5 only. For this one, 26. For this one, it's 66, 33. For this one, it's 75. So it would be 37.5. Okay. So these are the five or six thresholds possible. These are the 6 thresholds possible. Now, for a continuous variable, there is one extra step. So for categorical, we were just looking at, if I use this and it was a binary categorical variable, we were able to find out directly what is the impurity because of this split, because of this feature, because of this feature, because of this. Now, as we go to the continuous, we do not really have a situation to find out whether this would be a good fit or not. First of all, we have to evaluate for each of these threshold. Each of these threshold. So that means it would be something like this. Age less than 16.5. First would be this. I would like to calculate the impurity because of that split. Then if age is less than 20, what is the split because of that? Age less than 22.5, age less than 26, age less than 33, age less than 37.5. We will be calculating impurity of all these split. Whichever would be giving me least impurity, least entropy, highest information gain, that particular threshold will be picked up. That particular threshold would be picked up. So let's suppose that is coming out to be 22.5. That is coming out to be this particular one. So let's suppose this is the one. Now, I was getting least impurity because of this. Now the situation becomes like this. So we'll have for each, because of age, and we know where we were getting the least impurity, age less than 22.5. The overall impurity slash entropy is going to be this. Because of gender, because we had just two variables, it would be very direct. Impurity slash entropy would be this. Because of whether somebody likes spy movie or not, the impurity or entropy would be this. Now, out of these three, whichever impurity or entropy would be minimum, we would use that particular feature for split. If it is gender or spy, we know it's easy. If it's going to be age, then we already have found out the best threshold for that as well, because for age, the minimum impurity I was getting was for this one. So there is an extra step for the continuous variable, that first of all, we have to find out within that continuous variable what can be the best threshold that can be picked up. So we have to find out minimum impurity there or entropy over there. Once picked up, now we have a candidate for this feature, that what would be the least impurity I can get because of this continuous variable feature. What are the other features? Tell me what is the impurity because of that. Whichever would be giving me the least impurity, I would pick up that particular feature and would split. I hope the idea is clear. And using this way, we will be creating our overall decision tree. Okay. So now let's just take it for an example. So like we have got to know how do we split. So now we are into the final step of creating decision tree. Final step for creating decision tree. We know how do we create the split, best split. So I would not be getting into for each of the step how would we be splitting, because that involves a lot of calculation, as I already showed you. So what I'll be showing you over here right now is the same simple thing over here, that let's suppose the same question, somebody would like Dhurandhar movie or not. So let's suppose we have in total of 30 data points over here within this node. Okay, we have 30 data points, and for d equals 1, d equals 0. D equal 1 means somebody who likes, somebody who doesn't like. So we have around, let's suppose 17 data points for some people who like Dhurandhar, 13 who did not like. Now let's suppose I'm using a split of age, because I'm assuming right now that this was giving me the least amount of impurity or entropy, and I'm saying age less than 22.5. So because of that, I'll be getting a split which will go like this. So I'm saying over here now, what would be the total data points I would be getting? Let's suppose I'm getting 20 data points over here. I'm getting 10 data points over here. Now again, for d equals 1, d equals 0, I'll be having everything. So let's suppose this count is overall 16, or rather I should say 4 comma 16. 4 comma 16. Okay. And for d equals 1 and 0, let me say it's 8 and 2. Okay. So now again, I need to split over here. Yeah. Okay. So I would like to make it based on the basis of whether somebody likes spy movies or not. So somebody who likes is coming over here. Somebody who doesn't like is coming over here. Okay. So now on defining that, I'm already getting some beautiful pictures. So it was already 4. It was already 16. So I was getting something like this. That overall count I was getting over here was around, let's suppose 15. And 5 were present over here. Out of these, what I'm getting is, so I'm assigning it something like this. I hope I had 4. Oh, 17. It has to be like this also. I am not balancing it. My bad for not able to see this. Let me just do the scale. So out of 17 who liked, I need to just divide them as well. So for somebody, okay, 14 were present over, 20 are over here. So let's suppose, let's make it like this. And 3 are over here. So that means over here what I got is 7. Just a random scenario I'm picking up over here. This is 7. Over here also, again, I'll be getting something. So out of 14, I'm saying I was able to get around 13 over here, and this is 2. I'm getting 1 over here and 4 over here. So you can see I'm getting better clarity over here with respect to this. Now, if I just use one of the splits, so SPY had been used. If I use the gender, so I'm getting something like this. All the 13, D equals 1 is all the 13 I'm getting. And over here, what I'm getting is D equals 1, which is having 2. So that means 13 I'm getting over here, 2 over here. And for this one, okay, I would not really would like to split it. I will tell you the reason why. You'll get clarity with respect to with the help of this particular example itself. Now, with respect to this 3 and 7, I would like to again go ahead and let's suppose I was able to create something like this. That I used the idea of SPY movie only itself. What I got was I was able to get D equals 1 overall and D equals 0. That means all the 7 data point over here and all the 3 data points present over here. So the moment I have created this, so can you see this is a pure node? Let me just show it as well that I'm getting some pure nodes over here. What are the pure nodes? This is the pure node I'm getting. This is the pure node I'm getting. This is also the pure node I'm getting. This is also the pure node I'm getting. This is impure. Now you can see I'm getting 3 data points over here. I'm getting 7 data points over here. This is good. This is good. So that means if you just go through, you bring any particular data point, I would like to check what is the age. If it is greater than 22.7, greater than equal to, it will go over here. Again, I will go into whether somebody likes SPY movie or not. And if he likes SPY movies, he'll get over here and he would be definitely liking the SPY movie, the Dhurandhar movie. If he doesn't like it, he would go over here and that means he would not like. Similarly, we might follow this particular path as well, depending upon if age is less than 22.5. I'll just ask whether somebody likes SPY or not. If he likes, he would go over here. If do not like, we go over here. And then we have something like this. And this was the split because of gender. I hope you remember gender. Now, this is good, but this might not be good. Why am I saying having only 2 nodes in a leaf node is not a good sign? Because on basis of just 2 data point, I cannot say, and it would not be a good idea to say just because here I'm having only 2 member, whatever test test data point I'll be getting, I'll be just saying that he will also not like, because I had majority were saying that they do not like Dhurandhar. So that would not really be a good idea in that case. This has to be D0. Okay, they would not be liking because there are only 2 people. If there had been just 1 person, I would again say it is not a good idea. Just on the basis of 1 person, 2 person, I should not say that somebody would like or not this movie. So I might actually push for something like this: minimum data point for leaf node. We must have this thing decided so that it shouldn't be something like random, because if I'm getting just 1 data point in a particular leaf node, it doesn't make sense, because one person was 1 point should not be able to tell that what should be happening. I must get good number of data points. So I would say I will not be having this split at all. I would not split because I was getting just 2 data point over here. I would not like to go with the split. I would like to keep this one. similar to this one, because if I might have used gender, again I might have got 1 or 4, and one would be giving me just one data point in a leaf node. I don't want that. So this is again being impure, it's still fine. Okay, because over here I'll be predicting with some probability. We'll talk about that. And same if it had been pure nodes where we were getting some good number of data points, like at least 3. So for an example, minimum number of data point in a leaf node should be 3, at least 3. In that case, this makes sense. So if I'll be getting any data point, I'll say somebody would like the this particular movie because there are 3 other person who said they liked it within this particular kind of like following the same kind of a pattern, that they like the spy movie or not based on the age, based on the gender, all that stuff. Okay. Now, what did I mean by with probability? So over here, these were pure nodes, so we are clear. But over here, I'll be getting impure nodes. So what would be happening is I will be saying that with 13 by 15 percentage of, or whatever is the probability value I'll be getting, just do this division. With that probability, I would say somebody would like Dhurandhar. Okay. Similarly, I would say with 4 by 5, that means 80% of the chances are that somebody would not like Dhurandhar movie. So we would not be we are not always looking for the pure nodes, because if pure node means just 1 or 2 data point in that leaf node, that doesn't make sense. So sometimes we might want to maintain a good number of data points in a node, and then we would like to say with a probabilistic idea that overall what is the probability of saying that somebody would like or not. With that, I would like to predict what would be happening. And that is the overall idea of what happens in a decision tree. I hope I'm clear. I hope you're clear with how do we decide what should be the feature I shall be using for the split. Okay, it's entropy, Gini impurity index, or information gain. If I have found out the feature, I'll split. Again, I need to find out what should be the best split. For that, again, I would like to look for the feature. And if it's a continuous feature, any of the feature is continuous, within that, I have to find out the best threshold first, which I can use for the split. And then that would be a contender to, to be against the other feature, which might be categorical. Then it should be having least impurity or entropy to say that, okay, this continuous feature can be used as a split right now, okay, with this particular threshold. So that was the overall idea. Then there are other ideas as well. For an example, decision trees generally overfit. Why do they overfit? Because they are actually going by the training data a lot over here. And if we actually go for the pure nodes, it's actually the overfitting only if we are getting into more depth. Okay, the other thing can be pruning. So for an example, what we have done just now is it was something kind of a pruning only over here, that we actually avoided it because we wanted to have some minimum data point. So to avoid overfitting kind of a scenario, we actually generally limit either the depth of the depth of our decision tree, or we do some pruning, that we do not want the split because this is leading to some bad splitting. Okay, or bad kind of leaf nodes, though pure but bad, still bad. Those are the ideas, and there are again a number of things which goes into the decision trees, for which the questions can be asked, which can be the part of detailed discussion within the paid course. But I still feel that you must have gotten that what are the decision trees, how do we create decision trees, how are decisions taken, like what do we mean by decision trees, how those decisions for splitting, of deciding a particular feature to be used as for splitting is used. That idea itself is clear to you. Okay, so I hope you loved this session. And as I mentioned, this was the final session with respect to the important concepts or topics within machine learning. I hope you enjoyed it. You can always reach out to me in case you have any doubt. And that was all from my side. See you guys for other subject or maybe in the paid course. Thank you guys. I hope you enjoyed this session.